All right, today we're going to dive into a really powerful tool for any developer, the Builder pattern. We're going to see how it lets you build complex objects one step at a time, helping you dodge some of the most frustrating headaches in object-oriented design and ultimately build systems that are way more maintainable and scalable.
So let me ask you this. Have you ever been staring at a constructor that just seems to scroll on forever? This giant endless list of parameters for timeouts, cache settings, retry policies, credentials, and half of them are optional, which just turns your object creation code into an absolute mess? If you're nodding right now, you have definitely felt the exact pain the builder pattern was made to fix. And this nightmare, it actually has a name, the telescoping constructor. See, to handle all those different configurations, you end up making a bunch of different versions of the constructor, each with a different number of parameters. They all call each other, passing default values down the chain. Yeah, it's a classic code smell. It's brittle, it's a pain to read, and it becomes almost impossible to maintain as your object gets more complex. So what happens is, you're kind of stuck between a rock and a hard place, forced to make one of two bad choices. On one hand, you've got that monster telescoping constructor. On the other hand, you might try to create a separate subclass for every single variation. A read-only database connection, a read-write connection, a connection with custom pooling. You get the idea. And that leads to this massive explosion of classes that just clutters up your whole project. Neither one is a good path forward. But there is an elegant third way, and that's the builder pattern. What it does is it yanks all that object building logic out of the object's main class and puts it into separate builder classes. This lets you put together a complex object piece by piece, only specifying the parts you actually need. The result is code that's clean, super readable, and totally decoupled from the product you're building. So, how does this whole thing work? Let's break it down. First, you pull the construction code away from the product's business logic. Then, you define a common builder interface that lists out all the possible construction steps. Things like set connection timeout or enable retry policy. Then, different concrete builders can implement those steps for specific variations. You, as the client, just call the steps you need, and then, at the very end, you ask the builder for the final fully built object. Okay, so who are the main characters in this story? You've got the builder interface, which is like the blueprint for the construction steps. You have the concrete builder, which actually does the work of implementing those steps. The product is, well, the complex object you're building. The client is your code that starts the whole process. And finally, there's this optional but super useful player called the director, which we'll get to right now. And this is where the pattern gets really cool and flexible. Imagine a process to build a car, right? You set the seats, you install the engine, you add the GPS. A car builder could take those steps and assemble the physical parts. But, and here's the magic, you could also have a car manual builder that uses the exact same process. When you call set seats, instead of adding a physical seat, it just writes the chapter about seats in the user manual. You're using the same construction process to create two totally different things. So what about that optional director? Think of it like a recipe book for your objects. Without a director, your client code has to call each building step one by one, manually. But with a director, your client can just say, "Hey director, use this builder and make me a sports car." The director then knows exactly which steps to call, in what order to get that done. It hides all that messy logic and makes it reusable all over your application. Okay, so when should you actually pull this pattern out of your toolbox? Well, the number one reason is to kill a messy telescoping constructor. It's also perfect for when you need to create different versions of a product, just like our car and manual example. It's fantastic for building complex tree-like objects, and this one is huge. It can make sure the client never gets its hands on an unfinished, invalid object. Now, like with any pattern, it's not all sunshine and rainbows. There are always trade-offs. The big wins are clear. You get step-by-step construction, you get to reuse your code for different things, and you get this beautiful separation of concerns. It follows the single responsibility principle perfectly. The main downside? It definitely adds more classes to your project. You have to create this whole new family of components. The builder interface, the concrete builders, maybe a director, and that can feel like overkill for really simple objects. And this quote really nails it. It is all about control and precision. You're no longer forced to provide values for a dozen parameters you don't even care about. You get to surgically construct your object, calling only the building methods that are relevant for the exact thing you need to build at that moment. So, I'll leave you with this thought. The next time you're about to add another optional parameter to a constructor, or you're about to create yet another subclass for some tiny variation, just pause. Ask yourself, is this object a candidate for a builder? It just might save you and your team a world of complexity down the road.